Welcome to the fifth section, Classification and Regression. In this section, we will finish our deep dive into Apache Spark's machine learning library that we started in the previous section. In the last section, I introduced you to working with PySpark using the hands-on examples of building a recommendation system using the native SparkML library. In this section, I will show you the avenues of SparkML that we have not explored yet, with the accompanying examples focusing heavily on classification and regression. We will start with exploring some of the lesser known and less well-documented parts of SparkML. We will explore data sources and data types that are specific to the machine learning library, and we'll get to explore how SparkML handles vectors and sample data. You will learn how models can be saved and loaded, allowing for pre-computation of them and reuse. You will learn about ML pipelines, and we will also zoom in much deeper into the machine learning library, including all docs and examples that it ships with. By the end of this section, you should be able to find your way through the extensive SparkML library, and you should know how to approach implementing a use case of your own using Spark's machine learning library. Hence, this section will be a little less hands-on than the previous one, but there will be lots of new things to learn and discover. Welcome to the video, Machine Learning with Spark, What Gives? In this video, we will be revisiting the machine learning library's documentation in order to discover which things are important but not explicitly or easily available in the official documentation. Spark's extensive documentation is a great asset and often a great starting point for learning more about Spark, and hence is often the starting point of your journey when addressing or researching about how to solve or approach certain topics. Up until now, we have only touched the surface of all that is out there. Unfortunately though, Spark's documentation, and specifically that for the machine learning library, can sometimes be a bit chaotic and feel like it's all over the place, especially because there is so much of it. We have the machine learning library's main guide, the PySpark API guide, the PySpark SQL guide, the getting started page, GitHub, and the list goes on. It can be quite daunting navigating Spark's documentation and understanding what is there. I find that once you know your way around and once you know where to look for which topics, things get a lot clearer. Hence, I want to start off this section with addressing the documentation of Spark once more. But this time we are going to explore the lesser knowns and missing aspects first, before moving on to the more obvious topics in the later videos. In this video, I'm going to be taking the PySpark ML as the context from which we look at the documentation. And for this video, the focus will be on the utilities component. So before we continue any further, I want to take a look together at the GitHub of Spark. So right here, I have Spark's official GitHub page. I've opened the version that we're looking for, track 243. And here you can actually see in Spark Python PySpark, which is the package, of course, that we have been using, that you have the folder ML. Here you see the structure of the files that are inside of the ML library. And what I'm going to be wanting to show you throughout the next few videos that we're going to be making is that this folder structure, although it looks very similar to what we actually touch when we use ML API, you can see that it doesn't actually, or the file structure I should say, the file structure doesn't actually match with what you see inside of the library or inside of the module. I will be showing you some of the internals of PySpark that are actually handy to use, which is the reason why I'm going over to Git right now. Next up, which is important of course, is the PySpark ML API documentation, which we have covered before. So in this case, I've navigated to PySpark ML's API documentation, the main page. And what I want to do in the next few videos is actually break down the modules and the classes that exist in here for as much as possible, because obviously I'm not going to be covering every single class that exists. It's just way too many of them. But if you look at the left while I'm scrolling down, you can see that there is many classes and many modules as well. So you have modules at the main level and classes underneath them. So what I want to do is demystifying a little bit of what's going on in there. Specifically, the issue that I find with the documentation of PySpark, although it's very extensive, is that some parts are very missing. So sometimes some parts are lacking. There is some basic information that is assumed that people know, prior usage or something like that, which is not actually explicitly mentioned. And then there are many classes, because PySpark is nothing but a wrapper around what's actually happening inside of the JVM, so inside of the Scala and Java virtual machine. What you actually see is that every class that's in here has a Java equivalent, and if there isn't, there is a reason. Right, so the first thing that I want to do is actually go and what I call demystify. Right, so we're going to be covering all the modules in a few videos from now. For now, I'm going to be talking about the few specific modules that aren't explicitly mentioned in the ML guide, and I'm also going to show you some of the things that are blatantly just missing in the information. The first topic that I would like to address is Spark's linear algebra, and this is actually a module within Spark. The official Spark ML main guide, it makes actually no mention of this set of utilities that exist. So this is a problem because they are, however, crucially important to know about, because what linear algebra brings to the table is vectors and matrices. And the reason for the lack of documentation, as I like to call it, on the main guide That appears to be because of the partial feature priority that exists with the older RDD-based API that exists for machine learning. So what they have done, the documentation that is available on the specific topic on the linear algebra algorithms, it exists over at the RDD-based version of the ML guide, but it doesn't actually exist on the regular ML guide that we want to use. So before I continue any further, let's have a quick look at the ML guide, what I'm talking about, to remind ourselves about the topic at hand. So here is the machine learning library main guide, as it's called. So in this link here, this is the front end of the know-it-all, all-knowing documentation part of it, should be at least, for machine learning library. Of course, there's also the older RDD-based API guide, which is down here. And what I'm going to show you now is where in this guide, you can actually find some information regarding vectors and matrices. So here I went to the data types, which is the first entry inside of the MLlib RDD-based API guide. And here you can actually see some mention about what is called local vectors and also about a local matrix. There is some other mentions in here. For the purpose of explanation, you should ignore these because the only things that got backported from the RDD-based API into the newer data frame-based API are actually the local vector and local matrices. So let's have a look. Here you can find information about local vectors. And a little further down, you can find the information about local matrix. So I'm not going to go too far into what matrices and vectors are, but I will show you this slide. So specifically, the idea here is that vectors and matrices are very important data types when we look at data science approach of things, because you can actually store very complex information in a very effective way with matrices and vectors. So the nice thing about what has been done with the way that it's implemented in the linalg ML module, you can actually see the Python module that I'm talking about, is that the classes that are available to you, there's 5 classes in each one of these. So you have vectors, dense vector, sparse vector, and then there's 2 helper classes, which are just abstract base classes and wrappers that you can ignore, which is the reason why I grayed them out. But on the left side, you see there's vectors, and there's 2 types. You have the dense vector and the sparse vector. And the nice thing is that these are natively integrated with NumPy and SciPy. Right? So if you're familiar with a NumPy array, then you can actually store those natively as a dense vector. So you don't have to do any kind of back and forth thing or anything. If you have a NumPy array, you can actually just call it inside of PySpark natively, which is a nice thing about PySpark, and actually it's unique to PySpark. Then there's the sparse vector, which of course is kind of a different way of doing a vector. And these are natively available with SciPy. So the SciPy.sparse column vectors, which exist inside of the SciPy package, they also are natively back and forth between PySpark and Python. And on the right side of this, I actually added the matrices. Just like on the vectors, you have a dense matrix and a sparse matrix, which can be used throughout as well. So what you'll see is that there's examples available on side of this in the Spark documentation where they mention vectors, where they show that they are using it, but they never actually explain why and what they are, right? So I just showed you the documentation on vectors and matrices inside of the documentation. Obviously, the links will be on the slides. So if you want to learn more about them, make sure that you head over to the page on your own convenience and read about it. So having said that, let's head over to our Jupyter Lab environment. And let me show you some of the things that I've prepared to be able to explain how things work here a bit better. So when we navigate to the Mastering Big Data Analytics with PySpark folder, and then to section 5, and 5.1, the one that we're dealing with right now, you can see that I've prepared 4 notebooks, which I'm going to be covering just now. So the first one is on the linalg, which I just explained. So I've actually downloaded from the official documentation and put it all in here. Additionally, there's also some examples. Here you can actually see that I'm generating a NumPy array as a dense vector, and I'm just passing that as is. And here you can see that I'm generating a NumPy array as a dense vector, and how a sparse vector is very similar to how that looks. So this is from the official guide, the official documentation. I've made no adjustments to it other than just making sure that it is from ML rather than MLlib. And the same thing with a dense vector style example, where you can see that the NumPy arrays are just natively being actually passed onto it and how they are being cast into a dense vector. Same with matrices. So a bit of an explanation, classes once again, and also here what a dense matrix looks like and what a sparse matrix looks like. So explore these at your own convenience, play around with it, do with it what you like. Up until now, thus far, we have been using the data sources API from Spark SQL to load data and to manipulate data. There are some data sources that are specific to the Spark machine learning library that I would like to show you. So the first one that is important to know about is image or images. This one is available under PySpark.ml.image. And this module actually brings the ability to just read images. It doesn't mean that you can actually read the image data itself natively. Obviously, it is available and there are some manipulations there. I haven't prepared any really extensive examples, but what happens is that you can just basically use spark.read.format image, and then it allows you to iterate across image structures. So this is real nice to capture metadata and information on images or do some image manipulation, which, by the way, Spark isn't really good at, but it is an available data source. So I've also prepared a notebook for this specific purpose, the ML images one. And what you can see here is very similar as the last one. I have prepared some little example, which is actually also taken out of the official documentation. And what you see is that I'm using a kittens data set that is available within Spark itself. I'll cover that in a minute. And once you actually read, so here you can see I do spark.read.format image, so I'm reading images. I'm saying drop invalid, which is explained up here in the documentation about how that works. Loading the path, of course, and then selecting from it the image origin, the image height, the image width, and image number of channels, and image mode. And additionally, there's also the image data, but you can't really print that because it's binary data. So if you want to do that here, it will fail JupyterLab because it doesn't understand how to deal with that. But the image data is available. So the reason why I'm using .select here is because the image format returns a so-called struct in a column called image. So it's basically just like a nested JSON, which is called a struct. And in order for you to be able to parse that, you would have to select from that struct, which is what I'm doing with the select statement. So I'm saying select image struct dot get from their origin. That's basically how you have to read this. And the same with image height, image width, etc. Right, so to give you an example of what it looks like, here you have the file name, you have the height, the width, the number of channels, and the mode. Unfortunately, it doesn't really print that nice. Maybe I should do it like this. Yeah, this is an easier way to show it. So here you can see what I was just talking about. You have the origin, so that's actually where the file came from, the height, the width, the number of channels, and the mode. And like I said, there's the data as well, but obviously you cannot select that. I can show you what happens if I add image.data onto this, and it probably will fail. Okay, well, you can see that there is some information there, but it doesn't tell you anything. It's just binary information. Okay, so that's on images. Again, this information for this is actually available in the API guide, and also in the MLlib main guide has a brief mention of this as well. So at the bottom of this slide, you can see that I've linked to the API guide where you can find some more information on the image module. And also I put a link to the machine learning library main guide, which also briefly explains this format. The next topic is one that's actually a bit funny because it is not actually a PySpark class. So you will not find any information on this specific part of the machine learning library in any of the PySpark documentation. The reason for that being is because it is a source that is defined inside of Java or inside of Scala in the Java virtual machine. And what this is, it is support for the support vector machines library type, which is called libsvm. So this is a nice way of textually storing support vector machines, which is the thing that you might commonly have to do when you're dealing with data sets of this type. So instead of using a CSV file or a JSON where these support vectors simply don't fit, there's a native type called libsvm. So there's some general information about libsvm that I've linked on here, so you can see at the bottom of the slide. And also I've linked to the Java API guide where there is an actual explanation of what the class looks like. So this is available to you in PySpark because it uses the gateway to read from Java. There's no equivalent class in PySpark itself, like I mentioned. So what does it look like? So in order for you to be able to read libsvm files or write with them, you would have to use spark.read.format libsvm, just like we did with the images. So there's no direct spark.read.libsvm like we do with CSV files or like we do with JSON files. Instead, you have to use a .format notation. On this subject, of course, I also created a notebook. So let's check that one out. And just like before, same similar way that I have it set up. So I linked through a sample libsvm data file that's shipped in with the Spark here. And there's some general explanation about what the libsvm source is. And then I'm also reading one to show you what it looks like. So spark.read.format libsvm, like I just mentioned, I'm adding an option, this called num features, which is explained down here. There's also an option called vector type, which I haven't actually added, but then you can actually specify if you want a sparse vector or a dense vector. And then you use the .load, where you actually pass in the path that you want to load. So that is the notation that you need to use for libsvm. Then if you show the data frame, you can see that we have a label and features. And those features are where you can find your vectors. So your library support vector machines is this way, in this way is also supported. The next topic that I want to discuss is actually GitHub page for Spark. So what happens is Spark ships with some small data sources. You might have just had a little sneak peek of them already when I was using the kittens and the libsvm example. But what happens is that there is some small data sources which are used throughout the built-in examples of Spark, and they also use it for various things like unit testing across the various programming languages that are supported. And these samples actually are included into the Spark images. So let me show you what that looks like. So on this slide, I've made a little screenshot of the actual Spark on my local disk drive. So that's what it looks like on my Mac here. You can see in the mllib folder of that there is a number of files. They're all relatively small. You can see they're all in kilobytes, bytes. There's nothing really major, nothing big. So it's not going to break the bank in storage, which is the reason why they ship along. But they're very handy to just explore functionality or run the tests that are available inside of the documentation. If we have a short look at what actually is there on GitHub. So again, I'm in the GitHub page for Spark, and I've actually navigated to Spark data and an mllib. So I'm not in the PySpark package in the moment. It is just in Spark's native package. Like I said, these datasets are used across the various programming languages. So they're not specific to PySpark yet again. But here you can see the same as what I just showed you a screenshot of from my own machine. So you have those various text files, libsvm files. So you can see the libsvm in the name. And there's actually some images as well, which are very simple, but to show you, there's a kittens, and when you click on it, you can actually see that there's a picture of kittens. And as a little Easter egg, you might have seen that on the slide, just a couple slides ago, that I actually had the picture of this inside of when I was explaining on images. So over to our notebook, again, I've created a specific notebook that has to do with the data. So here you can see the data stored in mllib, this notebook. And what I've done here is I created a little helper function. You can check it out if you want to. But on the local drive of this notebook, which I'll show you as well, you can actually navigate to this path, which is the installation path for Spark 243. And inside of the data mllib folder, you'll find those same files that I just showed. Right, so here are all the files present in the data mllib folder. And additionally, if you're interested, I also created the YAML file, which is included inside of the notebook right here, which also includes all of these files, again, if you for some reason need that. So there's 2 ways of notation. I haven't included any specific examples with all these files. You can check them out on your own accord. What you will find is that all the examples that are listed throughout the Spark documentation usually use these as examples, unless they specify their own data. So it's very nice to be aware of this, and specifically if you want to test a function, if you want to try with something, you can have a look at this folder first and see if any of the data is available, so you can get a hang of it before you basically touch the real thing. I've opened the terminal window on my notebook, and I've actually navigated to that same folder that I just linked inside of the notebook over there. So here, if we just simply list out what's there, you can see all the files. In here, I'm in the actual kittens folder. If I navigate up a few paths, then you'll see mllib data. And here you can see all those files yet again. So have a look at this. An additional thing that is really not that important for mllib, but there are more datasets. So there's one for GraphX, which I've explained in one of the earlier sections, is not actually supported by Python. So if you ever want to mess with GraphX data, you can, but you would have to use Scala for that. And there's also data on streaming, which we'll cover in a later chapter. So for now, the mllib is what I've decided to show you because that's in scope of what we're looking at right now. Last but not least, utilities. So in the API guide, you'll find that there is actually one module called PySpark ML util. So it is a module that is not documented in the main ML guide for the very reason that all it really contains is internal utilities and helpers and a few mix-ins that are used throughout the various classes that exist. So you might see it, you might touch it, you can import it, but there's really nothing that you should have to do with it. If you ever feel the need to understand how Spark works, like more internally, and how it manages its ability to have default parameters and everything, you can feel free to explore this, obviously. But for me personally, I've never directly had to use it in any of the products that I in the products that I helped to build. But feel free to check it out, of course. I've linked to the API guide right here. I have not created a notebook on this for the reason that they are there, but really not necessary for you to know about other than to know that they're there. So I'd like to finish up here with the link to the learning resources yet again. So I've been linking to most of these throughout the various slides I just had. So the link to the main ML guide, the link to the API documentation for PySpark, and also the link for PySpark on GitHub, specifically the link to PySpark ML, which is what I've put on this slide. All the other information is on the other slides. Make sure to check them out when you want. And then let's just briefly recap what we've learned before moving on to the next subject. So I've showed you about Spark MLlib documentation, and specifically we zoomed in on the parts that are less explicit, or like I say, are not part of the main guide where you would normally expect things to be. There's various reasons for this, some being that they're not specific enough that they are mentionable, like the utils, for example. Others are because they're simply just only on the Java side, not on the Spark, not on the Python side, and others are for other reasons. So although the Spark MLlib documentation can appear disparate at times, which is exactly the reason why I was showing you the exceptions to the otherwise well-documented sections of Spark MLlib first, you do have to realize that all of the information is there, which I will show in one of the next videos. So I got to show you a little bit about pretty important parts of Spark and its internal functionality regarding machine learning library that were not specifically included in official guides. So factors and matrices are examples of this. The libsvm and image format are other examples. And of course, I got to show you a little bit about data that Spark ships with, which is used but not explicitly mentioned anywhere. So I thought it would be nice for you to be able to be aware of this if you ever want to just play around between quotes.